Good morning to all of you. Now I am preparing video for visually impact student. My topic is of inorganic chemistry, chapter 4th, alkanes and cycloalkanes. Now first we know about alkanes and cycloalkanes. Introduction. The simplest organic compounds are hydrocarbons, the compound containing only carbon and hydrogen. Depending upon the framework of carbon atoms in their molecules, the hydrocarbons may have either open chain or ring structures. In addition, they may be saturated or unsaturated in character according to the nature of carbon carbon bonds in them. Due to these variations, hydrocarbons have been divided into different classes. We shall discuss the various classes of hydrocarbons one by one, starting with alkanes and cycloalkanes. Now, structures of alkanes. Alkanes are open chain structured hydrocarbons having the general formula CnH2n plus 2, where N is the number of carbon atoms. They contain only single covalent bonds in their molecules. As such, each carbon atom is bonded to four other atoms, as is clear from the formula of methane, ethane, propane, the first three members of alkane. Formula of methane is C, and 4 hydrogen is bonded with the carbon atom by a single bond. Methane for CH4, ethane is CH3 single bond CH3, propane is CH3 CH2 CH3. The bonds in alkanes are formed by the overlapping of sp3 hybridized orbitals of each carbon atom with similar orbitals of other carbon atoms or 1s orbitals of hydrogen atoms. As a result, all the four bonds linking the carbon atoms with other atoms are sigma bonds. As these bonds are quite strong and are not easily attacked by other reagents, alkanes do not react with usual laboratory reagents under ordinary conditions. That is why they termed as saturated hydrocarbons or paraffins. It may also be noted that due to sp3 hybridization of the carbon atoms of alkanes, the four bonding orbitals of each carbon are directed towards the four corners of a tetrahedron. For instances, let us consider the case of a methane, the simplest alkene. In the formation of its molecule, the four sp3 orbitals of the only carbon atom overlap the 1s orbitals of the four hydrogen atoms, which are situated at the corners of a tetrahedron. It is a simplified three-dimensional representation of the molecule. In this representation, the wedge represents the bond pointing towards the observer out of the plane of the paper, and hatched line represent the bond going away from the observer behind the plane of the paper, and normal line shows the bond in the plane of the paper. Each carbon hydrogen bond has a length of 110 picometer, and each carbon hydrogen hydrogen angle is 109 degree 28 minutes. Similarly, in case of ethane and higher alkanes, the relative arrangement of bonds is always tetrahedral, although the different bond angles may be slightly different from the regular tetrahedral values of 109 degree 20 minutes. The carbon hydrogen bond length is about 110 picometer, while the carbon carbon bond length is 154 picometer or nearly so. On account of the tetrahedral arrangements of the four bonds formed by each carbon atom, the molecules of alkanes are three dimensional in nature. Again, repeat, the molecules of alkanes are three dimensional in nature. Moreover, in case of alkanes containing more than two carbon atoms, the carbon atoms of the chain do not actually lie along a straight line. This is quite obvious from the model of the propane. In fact, for higher alkanes, the carbon-carbon chains can assume a variety of zigzag shapes. But for the sake of convenience, the carbon atoms are written in a straight line so far as possible to have a planar representation, as shown. Now, classification of carbon atoms in alkanes. The carbon atoms present in alkanes can be divided into four categories as given below. First, that is primary carbon atom, we called 1 degree. It is a carbon atom which is linked directly to either one or no carbon atom. Second is secondary carbon atom, that is 2 degree. It is a carbon atom which is linked directly to two carbon atoms. Third is tertiary carbon atom, 3 degree. It is a carbon atom which is linked directly to three carbon atoms. Fourth one is quaternary carbon atom, that is 4 degree. It is a carbon atom which is linked directly to four carbon atoms. For example, the formula given below, there are 5 primary, 1 secondary, and 1 tertiary, and 1 quaternary carbon atom. This structure is of 2,2,4 methyl pentane. Hydrogen atoms are also classified as primary, secondary, and tertiary according as they are linked to a primary, secondary, and tertiary carbon atoms. Thus, in the example given above, there are 15 primary hydrogens, 3 each on the 5CH3 groups, 2 secondary hydrogen on the CH2 group, and 1 tertiary hydrogen on the CH group. अब है nomenclature of alkanes. The common and IUPAC systems of naming the saturated hydrocarbons are discussed below. First, we know about the common system. According to this system, the first four members of saturated hydrocarbons have special names, while the higher members are named according to Latin or Greek numerals indicating the number of carbon atom in the molecules. The names of all the members end in ane, that is A N E. Thus, CH4 name is methane, C2H6 ethane, C3H8 propane, C4H10 butane, C5H12 pentane, C6H14 hexane, C7H16 heptane, C8H18 octane, C10H22 decane, C20H42 ecosane. In case of isomeric alkanes from C4H10 onwards, the following distinctions are made in naming the various isomers. First is the hydrocarbons having all the carbon atoms in a straight or continuous chain are termed normal hydrocarbons. For example, CH3, CH2, CH2, CH3 is called N-butane, while CH3, CH2, 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 CH3 is named N-pentane. Second is branched chain isomers having a tertiary carbon atom are known as iso, while those containing a quaternary carbon atoms are termed as neo. Alkyl groups. The removal of one hydrogen atom from a molecule of an alkane gives a monovalent group called alkyl group. I again repeat, the removal of one hydrogen atom from a molecule of an alkane gives a monovalent group called alkyl group. It has the general formula CnH2n plus 1 and is usually represented by the letter R. The name of the alkyl groups are obtained by replacing the suffix ane of the name of corresponding alkane by YL. It may be possible to get more than one alkyl group from an alkane depending upon the position of the carbon from which hydrogen is removed as seen above. Second is IUPAC system. First is straight chain alkanes. The alkanes in which all the carbon atoms are present in straight chains are named by adding the suffix "ane" to the appropriate word root. For example, CH4 methane, CH3 CH3 ethane, CH3 CH2 CH3 propane, CH3 CH2 CH2 CH3 butane. Branched chain alkanes. In case of branched chain alkanes, the largest possible continuous chain of carbon atom is selected. The corresponding word root followed by the suffix "ane" is written down. The chain is numbered from the end, which gives the lowest number of the carbon carrying the substituent alkyl groups. If the number of substituent groups is more than 1, numbering is done from the end according to lowest set of locants for the branching alkyl groups. The names of branching alkyl groups along with their branchment numbers are then prefixed before the word root in alphabetical order. You can see this arrangement in 2-methyl propane or 2-methyl butane or 2,2-dimethyl propane. Some important points for giving IUPAC name. A few important points to be remembered for IUPAC names of alkanes are given as: first, if two alkyl different groups are equidistant from the two ends of the parent chain, the numbering of the chain is done in such a way that the groups which comes first in alphabetical order get the lowest number. Second one is if the group attached to the parent chain is also branched. It is named as a substituted alkyl group by separately numbering the carbon atoms of this group. For this purpose, the carbon atom of this group, which is attached to the parent chain, is always numbered as 1. The name of such group is always written in brackets. Third one is for deciding their alphabetical order, the complete name of the complex substituent, including the prefixes such as di and tri, forming the part of the name is considered. Fourth, while naming a compound, if two equally long chains are possible but the number of side chains attached to each possible chain are different, the possible chain having larger number of side chain is selected as the parent chain. Now, structural isomerism in alkanes. Each of the first three members of alkane, that is methane, ethane, and propane, can have only one structural formula. However, the higher members from butane onwards can be represented by more than one structural formula and thus exhibited structural isomerism. The various isomers of the same hydrocarbon differ in the framework of the chain of carbon atoms, and therefore isomerism exhibited by alkanes is termed chain isomerism. For example, butane exists in the form of two isomers, that is normal butane or isobutane, or we can say isobutane as 2-methyl propane. Similarly, pentane exists in form of three isomers, that is N-pentane, isopentane or neopentane. C6H4 exists in the form of 5 isomers, C7H16 has 9 isomers, C8H18 has 18 isomers, and so on. Natural sources of alkanes. Petroleum, which occurs naturally below the surface of the earth, is a mixture of many hydrocarbons, most of which belong to alkane series. Natural gas, which issues from petroleum fields, and fuel gases obtained from coal, contain lower alkanes. The waxy constituents of some plants have also been found to contain alkanes. For example, pine wood and turpentine oil